Welcome to this lesson on naming ionic compounds. In chemistry, ionic compounds are fundamental substances that we encounter daily. Understanding how to name them systematically is an essential skill for any chemistry student. Today, we will explore the rules and practice naming these important chemical compounds step by step. Ionic compounds are chemical substances formed by the electrostatic attraction between positively charged ions called cations and negatively charged ions called anions. When these oppositely charged particles come together, they create stable compounds. A perfect example of an ionic compound is sodium chloride, with the chemical formula NaCl, which is the common table salt we use every day in our kitchens. Every ionic compound consists of two main components. First, we have cations, which are positive ions. These are formed when metal atoms lose electrons. Common examples include sodium with a +1 charge and calcium with a +2 charge. Second, we have anions, which are negative ions. These form when nonmetal atoms gain electrons. Examples include chloride with a -1 charge and oxide with a -2 charge. Understanding these two types of ions is crucial for naming ionic compounds correctly. There are three fundamental rules for naming ionic compounds. Rule number 1, always name the cation or the metal first using its element name exactly as it appears on the periodic table. Rule number 2, name the anion or the nonmetal second, but change its ending to IDE. For example, chlorine becomes chloride and oxygen becomes oxide. Rule number 3, remember that the compound must be electrically neutral overall. The total positive charges must equal the total negative charges, even though we do not mention the charges in the name. Let's look at some simple examples to practice these rules. NaCl is named sodium chloride. Sodium is the metal cation and chlorine becomes chloride as the anion. MgO is magnesium oxide. Magnesium is the cation and oxygen becomes oxide. CaBr2 is calcium bromide. Even though there are two bromine atoms, we simply say bromide. Al2O3 is aluminum oxide. Again, we name the metal aluminum and the nonmetal becomes oxide. Notice we never mention the subscript, numbers, in the names of these simple ionic compounds. Some metals can form ions with different charges, and this creates a special naming situation. When a metal can have multiple possible charges, we must indicate which charge it has in that particular compound by using Roman numerals in parentheses. For example, FeCl2 is named iron 2 chloride, where the Roman numeral 2 indicates that iron has a +2 charge in this compound. FeCl3 is named iron 3 chloride, showing that iron has a +3 charge here. The Roman numeral system allows us to distinguish between different compounds of the same elements. Polyatomic ions are groups of atoms that carry a charge and act as a single unit. When naming compounds containing polyatomic ions, we follow a special rule. Keep the polyatomic ion name unchanged. Do not add the IDE ending to polyatomic ions. For example, Ca with NO3 in parentheses subscript 2 is calcium nitrate. We keep the name nitrate exactly as it is. Similarly, Na2SO4 is sodium sulfate. The sulfate ion keeps its name without any modification. Learning common polyatomic ions and their names is essential for mastering ionic nomenclature. Now it's time to test your understanding with some practice problems. Try naming these 4 compounds on your own before checking the answers. K2O is potassium oxide. CuSO4 is copper 2 sulfate, using Roman numerals because copper can have multiple charges. NH4Cl is ammonium chloride, where ammonium is a polyatomic cation. Fe2O3 is iron 3 oxide. With practice, naming ionic compounds will become second nature, and you'll be able to identify and name these substances quickly and accurately.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.